Let's explore this official GMAT problem. To get maximum benefit from this video, pause the recording now and solve the problem for yourself. And be warned, this is a difficult problem, so be prepared to spend extra time on it. The correct answer is D. I picked this problem out because it shows just about everything that you need to know about functions on the GMAT. So before we dive into this problem, let's take a look at what functions are. Functions are really nothing mysterious. They're really just like a machine or a box for changing one number into another number. Here's one that I'm pretty sure you already know. If I put a little 2 above a number, we call that the squared function. And if I put a number 4 into the box, then, hey, 16 is going to come out. If I have an input of -4, well, that's kind of interesting. 16 also comes out. And if I go wild and put p plus 1 into the box, well, if I do my algebra carefully, I can work out that p squared plus 2p plus 1 comes out the other side. So far, so good. Now, of course, in maths, we don't write boxes, we write little symbols, and the squared function is such a special one that it has its own symbol. We write x squared equals x multiplied by x. But I can also make up functions. Here's one, not a very interesting one, that I've made up. Let's call it the +7 function. So if I put 3 into the box, then 10 is going to come out the other side. And if I put y plus 1 into the box, well, y plus 8 is going to come out the other side. Now, interestingly, if I saw that, say, 4 had come out of that box, I could work out that somebody must have put -3 into the box. So I can also see what functions do in reverse. More about that later. But this function, because it doesn't have its own symbol, we can make one up. We can call it the g function, and we'd write g of x, meaning if I put x into that g function, I'm going to get x plus 7 out the other side. That's how you need to get used to writing functions for the GMAT. So far, so good. We've got a funny function here. If we put a 3-digit number, n, into the box, we get, well, what comes out? 2 to the power x multiplied by 3 to the y multiplied by 5 to the z. Well, that's pretty confusing. So I'm going to pick an example to help myself understand it. If I just pick any 3-digit number, let's call it, I don't know, 687, and I put that into the function box, I can see that I'm going to get 2 to the power of 6, 3 to the power of 8, and then 5 to the power of 7. Okay, so I can see what happens here. The hundreds digit, that's 6, becomes the 2 power, and then the 8, that's the tens digit, becomes the 3 power, and finally the 7, that's the units digit, becomes the 5 power. Okay, but that was pretty horrible, and I don't want to have to work out that big number. So let's pick an easier one. If I pick 111, I think that's going to be much easier to work with, because then what comes out of the box is 2 to the power of 1, 3 to the power of 1, 5 to the power of 1, and they're multiplied together. So that equals, well, I can work that out, that's going to equal 30. So far, so good. Okay, so can I put in plain English what this function is doing? It's taking a 3-digit number, and it's putting 2 to the power of the hundreds digit, 3 to the power of the tens digit, and 5 to the power of the units digit. Let's apply that to the question that they're asking us. We have some information about m and v, and then a relationship between f of m and f of v. Well, again, I think an example is going to help us. And hey, we could use one of the examples we've already come up with. Let's say that v is equal to 111. Now, I'm actually picking an example for v for a good reason. I'm going to multiply it by 9. That's actually going to be easier than dividing something by 9. So if v is 111, then we know that f of v is equal to 30, and therefore f of m is equal to 9 multiplied by f of v. Well, that's 9 multiplied by 30, which is equal to 270. So now if I know what f of m is, can I work out what m is? This is back to the question of seeing the number that's come out of the box and trying to work out what number was put in the box. In order to do that, we're going to have to look closely at the 2 to the power of something, 3 to the power of something, 5 to the power of something, because that's going to give us the hundreds, tens, and units digit of m. Hey, here's something we maybe didn't notice to start with. Those are all prime numbers. So really what I need to do to 270 is to do a prime factorization. I could say, well, actually, I already know that's 9 times 30, and the 9 is 3 times 3, and the 30 is 3 times 10, and the 10 is 2 times 5. Great, so we've broken it down into 3s, 2s, and 5s, and we can now say that f of m is equal to, that's 2 to the power of 1, 3 to the power of 3, 5 to the power of 1. Those three numbers, those three powers, are the hundreds, tens, and units digits of m. m is equal to 131. Great, so we're pretty nearly done with this problem. We just have to see that m minus v is going to be 131 minus 111. Don't get mixed up. That's going to equal 20. There's my answer, D. Phew. I'm not surprised if your head is hurting a little bit at this point. That was a tough problem, but it included lots of important things. And let's just reflect for a moment on the strategies and the thoughts we used to solve it. We tried examples to see how the function worked, and that's such a vital skill for not just functions problems, but many, many areas of the GMAT. We also described in plain English what a function does, and that's also really important and a very useful thing to do for many problem-solving questions. Finally, we were prepared to do some careful algebra, especially substitution. So go and apply these strategies to some other problems. Click the link below for a follow-up task.